Okay, let's see. Hopefully this is working. Oh, it's been a long day, everybody. Hello. Happy New Year to everybody. Hope you're having a good holiday season, or I guess, well, even those Orthodox people out there, I guess your holiday season's over by now. Okay. Anyway, welcome. It's been a while. So this is a video that I've wanted to do for a while. And I'm having so many technical issues getting this ready, but we're gonna try it again, and we're going live with it. So I've been wanting to do this video on basically looking at some of the work from Dario Nardi, and in particular his ERP studies or EEG studies, and how he's sort of mapped out brain activity and by the different MBTI types. And I'll explain in a minute here how that all works. But I found some images that purport to be from him, and I think they're from his Neuroscience of Personality book back from 2011. And I haven't actually read the papers, but I read his book and um, seen several of his talks where he goes over some of the results. But a few things stuck out to me that I thought were really cool and help sort of map some of this cognitive function stuff onto actual brain activity, which in my mind gives it a little bit more sort of scientific credence. For those of you out there who still think of it as like astrology or tarot cards or something. Um, but this is just me looking at these images and coming up with my own interpretation. So I don't want to ascribe anything to Dario Nardi or anything. I mean, maybe some of the stuff overlaps, but um, this is just my personal observations. So just want to put that out there. A couple of other caveats. Like I said, I haven't actually read, any of his published papers other than his book and seen his talks, but I can't argue for, whether this withholds, statistical significance and all that kind of stuff. I also don't know if any of this has been replicated or shown to be wrong in any particular way. So if there's anything out there sort of debunking this, certainly let me know. But again, I'm just taking it for face value. I should point out that I grabbed these images off the internet. So I don't know if these are the official images out of his book or out of his research. And I'm a little suspect because I've seen at least two versions of them out there. So hopefully this isn't like some doctored up version, because the data are pretty interesting and they map on very, very neatly to both the MBTI and all the other cognitive function models out there. So I'm hoping they're accurate and not doctored up, but again, let me know if that's not the case. Um, I also should point out that I'm not entirely sure what his methods were when he was collecting this data. I've seen at least one talk where he mentioned that basically people had these EEGs, recording their activity, and they were just sort of walking around the lab, just doing whatever they felt like doing. And it was sort of recorded over time as opposed to sitting somebody in front of a computer and having everybody do the same task at the same time. So the differences might be just because, people, the different types liked engaging in different parts of their brain over the course of an hour or however long he was recording. I don't think it's just everybody was doing the same task and they do it differently. But if I'm wrong, let me know. Um, Personally, I think it'd be more interesting if he really was just recording people as they go about, um, just sort of free range and just do whatever they want to do, because it does show like the parts of the brain that they probably enjoy engaging more than others. But again, I'm not entirely sure. And as always, my bold claims are for entertainment purposes only. And obviously this is a very different format than what you're used to. So all the SPs are probably happy because they'll get pictures, and all the SJs are probably happy because there's an outline of sorts that I follow. But there will be plenty of rambling. So, okay, well, let's get started. So, first, what we're looking at here, let me just sort of go over this and explain this. And also, if anybody shows up in the chat, I'm not going to be able to see you because all I see is the slideshow on my screen. So, apologies for that. But and it took me so long to get this thing set up. I don't know how to do it other than this way. Okay, anyways. Okay, so what are we looking at? So we're looking at the top of the brain here, or the top of the head. Nose is up here at the top. Okay. Ears are on the side. So this is the front of the brain. This is the back of the brain. These are the sides. This is the right side. This is the left side of the brain. Um, I should point out the frontal cortex. We're going to be talking about that quite a bit. Frontal cortex is up here. Prefrontal is at the very tippy top, right in front of the nose. Um, and then the second row is basically the frontal cortex and some motor cortex as well. Um, Frontal cortex goes back a little bit, but we start getting into the parietal lobe right around here in the middle. Definitely the second row up here is the parietal lobe. Occipital lobe is down here, and temporal lobes are on the side. So what are we looking at here? So he put electroencephalogram nodes on these different spots that you see where the little circles are. And what they're doing is they're recording the electrical activity of the brain as the person just sort of does some sort of cognitive task or something like that. And as they do these tasks, the different parts of the brain are going to become more active, um, because they're engaging in whatever sort of function or module, whatever process that they engage in. And the darker you see a spot or an area, that means there's more activity. And then the lighter areas means that there's basically no activity. Okay, so sort of graded here. Hopefully you can see with the darker, more activity, lighter, less activity, and somewhere in between. Okay. Another thing to point out is that, EEGs, they're definitely useful. They're great for recording activity, but the resolution, isn't as good as like an fMRI. And so you're going to get sort of big areas of the brain where, you might have different parts doing different things within a particular region, but it's close enough and it's good enough for what we're going to talk about. We're just getting a general sense of different brain areas. And I'll point out a couple of areas where, there might be more than one thing going on. But the other thing is in the frontal lobe, you get more activity in the frontal lobe, because the electrodes are, a lot of times are like on the forehead, so they don't have to go through the hair, and so you get sort of a cleaner signal, and so you end up getting more prefrontal activity anyway. But this is all averaged out, I believe, and um, but you just sort of get a cleaner signal up front, and so that's why EEGs and ERP studies have focused a lot on like frontal executive function type of tasks. As you get further to the back, it gets a little um, more diffuse. It's a little hard to narrow down areas, but again, it's good enough for what we're going to talk about. Okay, so let's see what some interesting results are here. So as you can see, he's broken, we've got Mr. ISTJ, we've got Mr. ESTJ, Mr. ISFJ, Mr. ESFJ, so all the 16 different types. Again, I think what he was doing, he just had them do various things around the lab as they were being recorded. I don't know exactly how long they were being recorded, and I don't know exactly everything that they were doing. I think they could sort of just free range do whatever they wanted. But as opposed to this just being sort of a snapshot in time where everybody was doing the same task but just doing it differently. I think that's the way it was set up, but certainly let me know if I'm wrong. I don't think it really changes anything. I think it just sort of makes it more interesting if this was sort of recorded over time, because you can see how they sort of engage different areas more than others, which we'll be talking about. Okay, so the first thing that stuck out at me is if you just look at the EJs, right? So lead thinking, lead extroverted thinking, and lead extroverted feeling. So ESTJ, ESFJ, ENFJ, and ENTJ. And the thing that you see here in the red circle, what I'm trying to focus on here, is you see in each of them the left prefrontal cortex is more active than the right. So you see it in the ESFJ, you see it in the ENFJ, and you see it in the ENTJ. Okay, so for each of the lead TEs and lead FEs, so those lead judging functions, you're seeing more activity in the left prefrontal cortex than the right prefrontal cortex. And we'll talk about why that might be in a second here. But then when you also add in the other types that have a lead judging function. So of course, this is the classic problem with MBTI, where an INFP who has a lead feeling function or a judging function has a P in their code, but their dominant function is a judging function. So don't let that trip you up. Just keep in mind all of these ones that are circled have either TE, TI, FE, or FI as their lead function. Okay. And even in the IPs, where it's either lead FI or lead TI, you're seeing more activity in the left prefrontal cortex than the right prefrontal cortex. Okay. Same with INTP, lead TI, more in the left compared to the right. ISTP, more in the left compared to the right. Again, lead TI, and lead FI, ISFP, more in the left than compared to the right. Okay, so this is true for each of the 8 types where they have either a thinking function or a feeling function as their dominant function. Okay, so it maps on very, very nicely, almost too nicely. That's why I'm a little worried that I got a doctored version. But again, I'm going to take this as, at face value here. Okay, so why is that? What are we seeing here? So let's talk about the left frontal lobe, and more in particular, the left prefrontal lobe. Um, and keep in mind that, this is just general neuroscientific, neuroscience discovery, using brain imaging, using neuropsych patients, all that stuff that's completely independent of the MBTI, right? So the stuff I'm going to talk about, where what people outside of MBTI, outside of cognitive functions, all of that, this is what the general sort of scientific community thinks is going on in the left prefrontal lobe. Of course, like anything in science, there's going to be nuances. There's going to be, some disagreements about terms, things like that. But I'm going to try to cover it as a high level as possible without getting into the weeds too much. Okay, so what's going on in the left prefrontal lobe? And again, this is completely independent of the MBTI. So first of all, we know it's driving working memory. So it's doing is what we consider executive function work. And your executive function is basically, controlling your planned and goal oriented behavior. Um, and what it's doing is basically pulling up working memory. Working memory is sort of your mental sketch pad. It's the part of your brain that can sort of hold on to a few items at a time, a few representations at a time. You usually hear like you can hold on to 7 plus or minus 2 numbers in working memory. That's what they're talking about. Like, how many representations can you hold on to working memory? That it's different than short-term memory. It's working memory. It's sort of what you're operating on in the here and now. Okay. Excuse me. So think of it like pulling up an application on your computer, like a Microsoft Word, or Google Chrome, some sort of web browser, where you pull it up, and now that it's active, you can work on it. Okay. And use your random access memory to do whatever processing you're doing, symbol manipulation, all that kind of stuff. Okay. So it's your mental sketchpad. And your left prefrontal lobe is that's what it's doing, is it's bringing this stuff up, and it's pulling in information from the back part of the brain. And we'll talk about the back part of the brain in a bit, but just for right now, it's basically just bringing stuff up and operating on it, figuring out what to do with it. Okay. And again, this is on the left side. And what it specializes is in routine or specialized behavior. So this is basically TE or FE type of stuff. Building up subroutines, figuring out, okay, if I'm working on a car and I'm familiar with a car, um, I know what I need to do as I'm operating on this thing, right? I'm familiar with basic subroutines. I might be facing sort of a new situation, but it's a familiar situation in the sense that I know cars, I know how they work, I know how to put things together, right? Or you could be cooking and you have a general sense of, turning on the stove, putting stuff in the mix, in the pots and the pans and stuff, and all that. And you might be facing sort of a new task or a new dish, but you have a general sense of how the stuff works, right? And how to piece things together. Very TE type of stuff, goal oriented, step by step, um, ordinal behavior. Okay. Same with the FE. So FE is interacting with people. I know this type of person, or I know this particular person and how they're going to act. And, if I say this, they're going to say that. If I say, then I'll say this, then they'll say that. This is how I get people to like me. This is how I schmooze with people. This is how I get people to leave me alone. Interacting, engaging with people is also sort of a frontal lobe um, executive function type task. Now, the frontal lobe actually breaks down into sort of two parts. There's the dorsal lateral prefrontal cortex, which is basically on the top here. And then there's the medial frontal cortex and orbital frontal cortex that are sort of underneath here. And so because the ERP again doesn't have that really high resolution, you're not going to see a split between TE in FE that you might see in like an fMRI or something. Okay. So, but you do see just this, activity going on up here in the frontal lobes with the TE and the FE folks. Okay. Um, as you would expect, right? Because that's what TE and FE is doing, this sort of goal oriented type of behavior. Okay. And so, but what about the IPs? What about the lead thinkers and the lead feelers? I mean, they're not necessarily doing a whole lot of TE, FE stuff, presumably. I mean, they could be doing some, but we're assuming there's some sort of difference here. So why are they lighting up too? Well, the prefrontal cortex is also responsible for sort of breaking things down, especially on the left side. So it's breaking things down and analyzing into sort of discrete components. Okay. So in the same way that TI and FI have to break things down to analyze, right? Where am I going to put this thing? How am I going to process this thing logically? Or how am I going to assign a value or a preference for something using my FI? The prefrontal cortex is also doing that, but it's interacting with some areas in the back of the brain to sort of sort out all that kind of stuff. Okay. And the TEFE stuff is more sort of front of the brain stuff, right? Like, how do I interact with this stuff outside of me? Where the TIFI type of stuff, like you could see here, there's not as much activity going on for the INFP up towards the front of the brain. It's starting these side parts, think of these as sort of folded underneath, right? And so you're seeing a little bit more activity on sort of these side areas, which we'll talk about in a bit. Now, INTP, he's a little bit of an anomaly, but we'll talk about him later. But in general, you see, with the EJs, you're going to see a little bit more activity up towards the front than compared to the ISTP, ISFP, INFP. So the IPs, less activity up here, more activity going on towards the side and towards the back. Okay, so prefrontal cortex is still engaged, but it's sort of breaking down and analyzing things a little bit more. Okay, we'll talk about that, what the temporal lobes doing, and the parietal lobes are doing in a bit here. Okay, so it's what they call context dependent behavior. I don't think I'm gonna belabor this point too much because I've done this video a couple of times just trying to get it recorded, and every time I talk about context dependent versus context independent behavior, I sort of flub up because it's well, just Google it. You'll see what I mean. But basically, context dependent is like, I know how to work with this thing, or I know how to work with this person. Um, and I just think context is a bad word for it. I would probably call it like object particular or something like that. Like, I know how to deal with this group of people, this person, this object, this, type of thing, because what it's doing is building up these subroutines, right? Um, on how to interact with things on the outside world, especially for the EJs. Okay. Um, Analytical. So this is an important point. The left part of the brain, it breaks things down into sort of analytical discrete components. Okay, so this is why it's responsible for things like language, mathematics, um you know sort of formal logic, that kind of stuff, where you have to break things down into discrete components, discrete representations or symbols, and you sort of manipulate them in your head and figure out how they work together, right? And that's what the left part of the brain is doing. So the left part of the brain is looking at the trees as opposed to the forest. Where the right part of the brain, the right hemisphere, is looking at more of the forest than the trees. It's looking at the big picture, the overall gestalt. It's not really breaking things down into sub elements or subcomponents or analyzing things. It's more looking at the bigger picture. Okay, and we'll talk about that on the next slide. Okay, so your deliberators, that have either a lead interface function or a lead deliberation function. So deliberators like TI, FI, they're breaking things down using this prefrontal cortex and doing analytical sort of processing. It's either logic analytics or sort of value based, preference based analytics that you get with the FITI. TEFE, they're doing that sort of subroutine, um, goal oriented type behavior. Okay. Now, of course, every type does every sort of function, but you're seeing sort of an obvious difference among the types here if you sort of think about it that way. Okay. So moving right along. So let's talk about the perceivers that have a lead perceiving function. So ENFP, ENTP are lead NE folks, ESTP, ESFP are lead SE folks, right? So the first thing you're probably going to notice is they have more activity in the right frontal cortex compared to the left frontal cortex. More activity in the right compared to the left, more activity in the right compared to the left, more on the right compared to the left. Now, of course, just like everybody, they've got some activity going on both sides, but they seem to show this, quote unquote preference or just more activity going on the right side than their EJ counterparts, right? And then let's add in the IJs. And again, problem with MBTI, even though they have a J, they actually have a lead perception function or perceiving function, either SI or NI, right? So ISTJ, ISFJ, or they have lead SI, more in the right compared to the left, more in the right compared to the left. INFJ, INTJ, lead NI, more in the right compared to the left, more in the right compared to the left. So each of the 16 types maps on exactly how you would think they would when it comes to right brain versus left brain prefrontal cortex stuff, right? Or at least they're organized in a very um, definitive way, right? Um, so let's talk about what the right frontal lobe is doing. So again, we're talking about the SE, SI, NE, NI DOMs. Okay, lead action functions or knowledge functions, depending on if it's SI, NI, or NE, SE, right? Okay, so the right frontal lobe, what it's doing is so, unlike if you compare it to the left frontal lobe, again, the left frontal lobe is building out your mental sketch pad and figuring out, okay, what information do I need to work with and operate on to engage in this sort of goal-oriented behavior, right? So either in figuring out how to engage in something with something out in the world or how to interface with it, a person, an object, or how to break it down and analyze it in sort of a TI or FI way. Okay, that's what the left prefrontal cortex is doing. Very analytical, very step by step kind of, discrete process. The right, on the other hand, it's not really pulling stuff up as much as just sort of reading the environment. Okay, so it's being fed information. I should point out, basically your visual system here, the visual input, it goes through your eyes are right here by your nose, all right, but all that visual information actually gets fed straight back to the back occipital lobe, and it starts back here. And this is just sort of your general senses, and then it sends the information in two pathways, up the temporal lobe and up the parietal lobe. Temporal lobe is basically like identifying it, what you're looking at, and then the parietal lobe is basically like spatial awareness, like where is this thing, is it moving towards me, that kind of stuff. Okay, so you're getting all the processing about the environment, about the actual sensory information, and also stuff coming in the ears, right? It's all getting processed right here in the back of the brain, but it's interacting and it's talking to the front of the brain. And what the front of the brain is doing with all these perceiver types is it's figuring out, okay, what the hell is going on out there, right? And not in sort of a verbal descriptive kind of way, because that's your left part of the brain, but more of a gestalt, like, is this thing a forest? Is this a beach? Am I in an office building? Am I in a car? Am I in a house? Am I in an elevator? Am I in a basement? Where am I? And it's obviously taking in cues, and it under and you're going to be noticing various objects that sort of cue you in to where you are. But there's also this gestalt thing going on that is hard to articulate, because it doesn't break down into verbal components, right? It's a holistic picture that basically tells you you're in a nightclub, or you're in a restaurant, or you're in a basement, or you're locked in somebody's trunk or whatever, right? And it's basically tying all this stuff together and creating this sense of environment and what's going on in the environment. And so it's driven by the environment, and so it is getting input, right, from the back of the brain, that's sort of identifying things and telling you where they are, but it glues it all together up here, and basically tells you, where am I? Um, and also sort of what's the context, right? Like, am I being threatened? Am I safe? Am I good? The ISFJs and the ISTJs who need that, who have that lead SI, right? Am I safe? Am I comfortable? That's all the stuff going on up here, because it's also tied into the limbic system as well, right? Um, okay, so, and then of course, it's context independent, so it's not tied to a particular object or anything. It's actually kind of creating the context, and again, that's why I don't like the word context in this way. Um, so feel free to Google that if you want to go down that rabbit hole. It's very spatial, right? So piecing together things in the environment, knowing what's going on around you, you're going to need some spatial processing, obviously, and it's very continuous, right? It's not like, again, compared to the left side that's breaking everything down into individual representations and symbolic representations. It's looking at the whole. It's looking at, is this thing flying towards me, right? Or am I in danger? That kind of stuff. Very continuous. It's going to be picking up on motion. It's going to be picking up on emotions, like, or how are people acting towards me? Are they acting threatening? Are they acting, are they cool? So you get some FI stuff going on up here too, but not in the FI that we're sort of used to. Do I like this thing? Do I not? It's more of, a big picture, like, what's going on here, kind of thing. Okay. But it's, obviously they're talking to each other. None of this stuff is in a vacuum unless you have your corpus callosum severed. And that's the part that connects your right brain to your left brain so that they can talk to each other. And there actually are patients out there where it's severed, and you get a lot of interesting results. And that's how we know a lot of this right brain versus left brain kind of thing, because they sort of have two different consciousness is going on inside of them. Look up split brain patients. It's very interesting stuff. Okay, so we could see why the perceivers, the SIs and the NIs, are going to have more activity going on up here because they're just sitting back and observing a lot of times, right? They're focused on what's going on in the environment. Now it could be, the physical environment, like what you're getting with the SI types, or the SP types, right? Focusing more on physical stuff. Or it could be what's sort of metaphysically going on. Like, how would you describe this situation? And again, not really in language terms so much as just sort of like when you hear a song and you're not really you don't really think of the genre so much as just sort of the feel. Like this song makes me feel good, that kind of thing, right? Or this is the type of movie that just is like aesthetically pleasing, and I can't really explain why. It just is, right? That's all this right brain stuff. Okay, let's move on here. Okay, so that is this right brain versus left brain prefrontal cortex is what immediately stood out to me. And again, I really hope that this is the original data and this wasn't doctored somehow, because it maps on so cleanly um to the cognitive function theories. And you don't have to do a whole lot of like mental gymnastics to make it work, right? um it really is what you would expect um, with the different types. Okay. Um, all right. So let's start talking about some of the other functions. So the action types. So your NESE or extroverted perceivers in MBTI terms. Um, what's going on with them? So remember, I had talked about how up here on the second row is the motor cortex. Okay. And so what the motor cortex is doing is it's sort of planning behavior. And it actually, it's when you're moving your arms and moving your legs and your fingers and your toes and all that, this is the part that's making all that stuff happen, right? But not only does it fire off signals to make you move, but it also does planning. It also is sort of observing what other people are doing. So this is the mirror neurons, where if you record activity in here and they're just in, especially in monkeys, you see this. If they're watching other monkeys play with a ball, then like their motor cortex starts firing as if they were playing with the ball. um that kind of stuff. Okay. So this is about action, right? And both in terms of actually doing it and sort of planning for it. And so what do we see? Well, we see Mr. ESTP, Mr. Action, Mr. The doer, right? The ESTP, all about action right up here, right? Exactly as you'd expect. Now, again, he might be just sort of flying all over the place, doing a million things like an ESTP might, or he might just be thinking about it or planning on it. Um, but there's certainly a lot of activity, about engaging with the world going on here in the front, right? And the frontal cortex, again, his right side is going to be talking to this a lot, trying to pick up on environmental cues, trying to pick up on, you know how do you react to these environmental cues. Now, that being said, the ESFP is sort of an anomaly, right? You'd sort of expect the ESFP, who also has lead SE, to have a bunch of activity going on here as well. And I have a little bit of a theory on it. And it has to do with this area right here, right? Which is right above the ear on the far left side. And that, I'm going to go up to the ENTP and ENFP to talk about that, because it makes more sense in that context. And this is what we call Broca's area, or at least Broca's area is part of this overall area. And that is largely tied to generating language. So not only moving your mouth and you know sending air through your vocal cords and producing language, but also like knowing how to produce it, like the syntax and how to write it, how to communicate. Um, People with Broca's aphasia, where they've got damage to Broca's area, they have a real hard time producing language. Okay, now understanding language, understanding what somebody's saying to you, is more in the back of the brain, because that's more about representations and figuring out meanings of things, which we'll talk about in a second. But the front of the brain is about production. Okay, and so down here with the ESFP, well, let's go back to the ENTP and the ENFP. This is exactly what you would expect. These people are probably talking the entire time, like an ENFP and an ENTP would, right? Lots of activity, heavy duty activity going on in the Broca's area. Um, and they're just the chatty Cathys, right? Just talk, 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 talk without, and not a whole lot of like actual physical activity going on, but a lot of language, metaphysical sort of mapping going on here, right? A lot of talking, a lot of chatting. The ENFP and the ENTP. And I think that's probably what's going on with the ESFP down here too. So the ESFPs, I mean, they can talk too, right? They got a lot. Um, they could be some pretty chatty Cathys too. Now they're not. They might not be talking about big ideas as much as like the ENTP and the ENFPs might be, but they can certainly talk your ear off, right? And so, and like, I've described in some of my other videos, if you've got your NE sort of engaged, it's probably going to be turning off your SE, or inhibiting it. And so this was probably just a chatty Cathy and was probably spending a lot of time talking, right? As opposed to the ESTP counterpart, some talking. ESTPs definitely can talk, and was probably doing a lot of wheeling, dealing, and planning here. Okay. So, real interesting results there. Now, some other things that stuck out to me that were kind of weird and kind of off, though. I got to acknowledge the other stuff too. First of all, ESFJ, this isn't as weird or off, but ESFJ was definitely talking a lot too. Look at all this activity. This is just like classic, just like talk your ear off, all up in your business. ESFJ. And then again, a lot of sort of motor planning type activity. This person was just all over the place, like the ESTP was, right? A lot of talking. So Chatty Cathy, ESFJ. But the other thing that stuck out to me though is look at the INTP. Like, what's going on with this guy? Now this guy is definitely an anomaly. You would not expect as much, action. I mean, he's up there with the ESTP when it comes to action. So few things. Either this guy was just like geeking out about something, or was like engaging and like programming something. He might have been just geeked out about this whole experience of having his brain recorded and was just trying to figure out like how all this stuff works or something. Who knows? But way more sort of front of the brain activity than you'd expect in sort of in an INTP. Because if you compare him to like the ISTJ, pretty quiet up here, some talking, not a whole lot. But look at the ISFJ, no talking, just sitting, minding his own business. I'm just gonna sit here. You do your thing. I'm just gonna politely, I mean, this is just classic ISFJ, right? Just politely sitting down, not really moving around. Maybe something going on here, but not a whole lot. Not a whole lot of talking on either side, right? Same thing down here with ISFP. A little bit of talking, like the ISTJ, not nearly as much. But just kind of hanging out, chilling out, not being too active. You also see it in the INTJ, ISTP, of course, as well, right? Not a whole lot of activity in the INFP. Sitting there doing some talking, definitely doing some talking. It has that secondary NE, right? Um, but and who else is gonna have the secondary NE? Um, Oh yeah, the INTP. The INTP is all over the place. He's probably explaining to everybody like how all this stuff works. I don't know. But anyways, INFP, INTP, they can be chatty too, right? Okay. But not a whole lot of moving around, not a whole lot of action from the INFP. You know, one might even say SE Polar here. Definitely not SE Polar here. Again, he was having a rare day, a red letter day for an INTP. Okay. So like I mentioned, INTP stands out, ESFJ stands out as being the chatty Cathy um, for these two types. Okay. Not for the action types, but I found that real interesting. So let's move on now to the parietal lobe. So now we're going to talk about a totally different function, totally different part of the brain. Um, Now, this is a little bit controversial, sort of in the general neuroscience area. Now, if you ask, the majority of sort of, neuroscience people, researchers, where does logic and reasoning happen? Most people will tell you left prefrontal cortex, and for good reason, right? If you get damage to that area, you have a hard time breaking things down and analyzing things. Okay. So, not very surprising that a lot of logic and reasoning happens up in the left prefrontal cortex, like we talked about. Because you have to be able to sort of pull things up, work on it in working memory. If you're going to do a math problem, you got to be able to hold on to the information and operate and all that kind of stuff. However, the parietal lobe is also so the parietal lobe's back here. So the three um, square or sections on the second row in the middle. Okay, temporal lobes on the side, parietal lobe up here, maybe a little bit of parietal lobe up here as well above this second row, but mostly the second row. Okay, so so the parietal lobe is usually thought of as doing sort of spatial um, processing, so figuring out where things are. Um, it's connected to your motor cortex, and so it's sort of telling you how to move your body and where to move your body, where to move your hands, where to move your legs, that kind of stuff. But also just where things are in space, right? If you need to reach out and grab a cup, you're going to need your parietal lobe to tell you where that cup is. Okay. Um, Now, that being said, it also seems to have some function with logic and reasoning. Because if people get damage to this parietal lobe, they're going to have problems with the transitive inference test that I've talked about before, where you have A is greater than B, and B is greater than C, and C is greater than D. Is A greater than D? And just through transitive inference, through pure logic, you can figure out that A is greater than D, right? And so when they have damage to this area, they actually have problems with that kind of logical reasoning. And not just that, but other sorts of logical issues. And also, if you put somebody in an MRI machine and have them do that transitive inference task, you're going to see some activity here in the parietal lobe. Okay. Um, Now, one explanation could be when you're doing the transitive inference task, you might think of it and sort of put it in your mind's eye. You might say, okay, I'm going to put the A on the left side, and then I'm going to put the B next to the A, but to the right of it, and then C to the right of the B, and then D to the right of the C. And then that way, in my mind's eye, I sort of have everything organized in, from biggest to smallest, left to right. Okay, so that might be why the parietal lobe gets engaged, because it's sort of treating the transitive inference task as sort of a spatial reasoning type of task. And that might be a big part of it, but it's also, you could think that that might be where logic came from in the first place, right? As we developed and evolved as a species, we might have had this part of the brain that sort of developed in one way or another, that figured out how to organize things in sort of a meaningful but yet spatial way, right? The big stuff goes on the left, the little stuff goes on the right. And then through evolution and, thousands of years of development, we somehow figured out how to read that and translate it into logical processing. Okay, so what do we see here? So logical reasoning would be a TI type of function, right? So with our INTP and our ISTP, where TI is a lead um, function. You see a lot of activity here in the ISTP, right? See, not as much activity in the INTP, but again, he's doing something. He's doing something. I don't know what he's doing, but you still do see activity where you would expect to see it, right? Lead TI. And then with the ENTP, ESTP, where TI is in their second function, um, tool function here. Again, a lot of TI activity going on. A lot of TI activity going on. Um, and then with the ESFP, where TI is polar, see a whole lot, right? And with you do see some with the ENFP though. So, again, it's not perfect. Um, okay. So, this could be where a lot of TI is going. And you might be thinking, okay, well, wait a minute. I thought TI was like a left brain thing as opposed to a right brain thing. Well, it could be that they're just sort of engaging in spatial type of reasoning, and that just ends up being more right brain. It also could be like, if you look down here at the ISTP, there's just a lot of talking, and it could be it sort of starts up here and moves over to the left, and the left sort of breaks things down. Who knows? That is, it's a valid question. Why would it be on the right brain versus the left? And again, it could just be because what's going on is it's sort of the whatever logic processing they're doing is sort of a spatial nature to it. Um, so I don't know. I just found that interesting. Um, okay. Oh, and also our chatty Cathy, not a whole lot of TI going on here. So I don't know what the ESFJ was talking about, but hopefully it made sense. Okay. But also to pick on myself, the INFJ, not a whole lot of TI going on here, but that was probably because something else was going on, which we're going to talk about at the next slide. Okay, so that's our TI. Now let's talk about temporal lobe. Okay, so the temporal lobe, like I was saying before, let me find a good person to start with, right? Okay. Um, so let's start with the INFP here. So again, visual information comes in through the eye, and then it goes down the optic nerve all the way back to the occipital lobe. And actually, technically, if it comes in the right eye, it goes back to the left part of the brain. It's really weird. It crosses over. Um, but anyways, so this part of the brain, the occipital lobe, is just looking at basic, very, very fundamental stuff like shape and maybe color. I mean, actually, color gets processed even higher, but basically just like general shapes, right? So it's just telling you that something's there. It's not telling you what it is. It's just something's there, right? There's an object there. And then as the processing moves up, it starts sending signals up through the temporal lobe. And the next step in the temporal lobe is basically identifying it. What is that thing? What is that object that's, getting my occipital lobe to fire? And sorry, had a little mental break there. But anyways, so then it's identifying, okay, what is that object, right? And so when people get damage to this area part of the brain, they can see things, but they can't identify them. Okay. And there's this area, Wernicke's area, which is again involved in language processing, but it's involved in understanding what's being said as opposed to generating the language. So back here, you're identifying stuff as the signal sort of moves through the pathway. Okay. And then the next step is what we would call the anterior temporal lobe, and it's sitting right here next to the ears. And what this is doing is now, you go from identifying an object to now making more sort of abstract connections, associations about the object. What, you know, not only what is it, but what are some of the sort of abstract qualities about it. So, for example, if you see a piece of ice sitting on a table, this back part of the brain is telling you that it's a piece of ice, but the more anterior part or the more frontal part of the temporal lobe is telling you that it's cold and that it's probably going to melt. More abstract knowledge about the ice cube. So, what does that sound like? It sounds like NI, abstract knowledge tying together associations between concepts. It's also what we consider sort of the semantic network is going on right here and tying together concepts. So, what do we see? The INTJ, INFJ, lead NI. See a whole lot of activity right there on the anterior temporal lobe, exactly where you'd expect it, right by their ear, right? So if you put your fingers by your ears, that's your anterior temporal lobe. Okay. And again, abstract knowledge about things, not necessarily what they are, but how they sort of associate and sort of deeper meanings. Okay. Um, you also get it on the right temporal lobe. Okay. Not as much activity here with our INFJ, um, but you see some with the INTJ. And again, it's not going to be as discrete information and verbalizable, but it's kind of like archetype information almost. It's like you know it when you see it kind of stuff. Like you know that's a good song, that's a song you like, but you can't really articulate why you like it. You just, there's some meaning to it, or aesthetics, things about a movie, the fact that you're watching some movie and it's got a bunch of symmetry to it, and you might not even identify it as being symmetry, but you just know you like it, right? Just sort of these abstract, I don't want to say feelings, but processing, that's sort of high level, making associations between things. Okay. And also with our ENTJ and ENFJ friends who have NI as their second function, you're seeing a whole lot of activity right here in the anterior temporal lobe. Okay, exactly what you would expect. Okay. So, also with our ENTP friend, lots of activity going on because ENTP is totally being a chatty Cathy, talking everybody's ears off, has some sort of idea about what's going on. Probably trying to figure out like all this ERP stuff, all this EEG stuff. INTP's totally got to figure it out. The ENTP thinks they've got to figure it out, but we'll see. Let's see who else. INFP, you're getting a lot of activity again. INFP and ISFP, you see a lot of activity around. This is sort of the side, but also sort of the under part of the brain. If you look at sort of a side view of the brain, there's that part that you know sort of folds under. That's kind of what's going on here. ISFP. I'm wondering if the ISFP was left-handed. That might be why. But anyways, but again, lots of activity here. They're looking at big picture kind of stuff. Big picture meaning ESFP. Go ESFP. They got something going on here. They locked into something, some sort of NI type of thing. I don't know. Maybe this is Joe Rogan, and they locked on. He locked onto some sort of conspiracy theory or something. Um, ESFJ. Now this one sort of stood out to me because the ESFJ and the ESTJ should be unipolar, right? But we do see activity. There is stuff going on. But also keep in mind that again, this is ERP and you're processing audio information through here too, right? So it's not, this part of the brain, even though I'm acting as if it's like your NI center, and there is probably a lot of NI stuff going on here, but there's also some audio processing going on. And if this ESFJ was just like a total chatty Cathy and talking the entire time to somebody, then maybe there's just a lot of, audio information sort of going in and out. So, you can't, nothing here is dispositive or determinative, but it is sort of fun to think about. Um, Not really a whole lot of people are showing no activity, so they're all kind of engaged. I mean, I guess the ESFJ over here, right? I guess that would make sense for a polar, right? I mean, I guess because everybody's showing some level of activity. Oh, the INTP. This guy, man, he's throwing me off. I don't know what's going on with this guy. He was on too much coffee or something. I don't know. But you wouldn't expect him to be low on the NI over here, but he was distracted. He had something going on. Maybe he was just talking to the ESFJ. Maybe that's what was going on. I don't know. Anyways, all right, cool. I think I've babbled and theorized long enough, and I have no idea if this is even recording. God, I hope it is, because I don't want to have to do this again. All right. Thanks for watching. Feel free to leave me a comment, especially if you know anything wrong with these studies, because I'm purely going off of this thing I found off of the internet, and I will fully retract everything if it turns out that this is all just bullshit or or bogus. Um, but it does line up. It lines up so nicely, almost too nicely, like I said. So let me know, for those of you who are keeping score at home. Okay, cool. Everybody have a good weekend and talk to you next time. Thanks.